the nucleus of an isotope of a xenon atom is 6 femtometers in diameter. It has 54 protons and a charge Q, which equals 54e. And E is just the charge of a single proton or a single electron. Okay. What is the electric force on a proton 2 femtometers from the surface of the nucleus? And B, what is the proton's acceleration? So we know that the proton here is 2 femtometers from the surface of the nucleus. Okay, so this is the nucleus, by the way. And then this is the proton. Okay, so it's asking for the electric force, right? We know that if we treat the nucleus as a point charge, in that case, we can use Coulomb's law, and force electric equals K Q1 times Q2 over R squared, where R is the distance from the center of the nucleus to the center of the proton. Okay, and K is just a constant. Okay, that's the value of K. So, force electric equals 8.99 times 10 to the power 9 Newton meter squared over Coulomb squared times the charge of the entire nucleus, and that is 54 times the charge of a proton, that's 1.6 times 10 to the power negative 19 coulombs, times Q2. Now Q2 is the proton itself, so 1.6 times 10 to the power negative 19 coulombs, this whole thing divided by R squared. Now, like I said before, R is the distance from the center to the center. So we're going to have to divide 6 by 2 because we want the radius and not the diameter of the nucleus. And that gives us 3. And then we add 2 to that, and that gives us 5. The radius of the proton is basically negligible. So we can just write 5 times 10 to the power negative 15 meters squared. Okay. And if you're wondering where this comes from, that's because 1 femtometer is 10 to the power negative 15 meters. Okay. If we put that into our calculator, approximately the value is 497.11. You could also just round that up to 500 newtons if you really want. But I'm going to box this answer because it's a bit more exact. Okay, part B. What is the proton's acceleration? This is an F equals ma problem. So A equals F over m. And the force is 497.11 newtons over the mass of a proton, that is 1.67 times 10 to the power negative 27 kilograms. And that equals 2.97 times 10 to the power 29 Newton over kilograms, or meters per second squared, whichever one you want. But this is our answer.